looking at example 1.
The following data represent the muzzle velocity in feet per second of rounds fired from a 155 mm gun. For each round, 2 measurements of the velocity were recorded using 2 different measuring devices, resulting in the following date. Is there a difference in the measurement of the muzzle velocity between device A and device B at the alpha of 0.01?
You see that there are 6 observations. That means n is 6. Here's the result from device A. Here's the result from device B. Because we are looking at a dependent pair, therefore we use the matched pair, t-test. We need to calculate the d-bar, in essence, the bar, the mean, also S, which is the sample variance. Very first thing we need to calculate is the difference between the two. This can be done by hand or by a calculator. So here's what we need to do. TI calculator command is given here, step by step. The very first thing we need to do is to clear the screen, list L1 and L2. So not only we clear list L1 and L2, because we need L3, we are going to clear that up. We're going to input the observation in L1 with the observation in L sub 2. L1 minus L2 is stored right here, stored in L sub 3. So we're going to store it. It creates a new set of data. We do one variable stats on least L sub 3. We do the calculation and the result follows. Here's the X bar. Here's the S sub X. X bar is the same as D bar for us, and S sub X is the same as S sub. Why are we using S sub X and not sigma X? Because this is a sum. Now that the D bar and SD has been calculated, we are going to do the test of hypothesis. The very first step, H0 and H1. This is a two-tailed test. Mu sub D is 0 as H0 and H1 mu sub D is not equal to 0. The next step is to calculate the test statistic. T equals D bar minus mu sub D over S sub D over square root of N. Mu sub D bar comes from H0 always, and therefore it's 0 for us, or at least in this course. Calculation will result in negative 0.6411 for test. Or we can use a TI calculator command again. It calculates for us, and it gives us the T negative 0.6411247797. Use a few decimals. It also calculates the value of P, the P value. So let's look at the next step. Have a choice of using the critical value or the P value. I want to go over both methods. Critical value comes from the choice of alpha, which happened to be 0.01. Degrees of freedom is n minus 1, makes it 5. Looking up the T table, T equals plus minus 4.032. We could also use a calculator using inverse T. P value, it's equal to 2 times the area to the left of test statistic. Because the test statistic is negative to the left of that, it were positive to the right of that. And because it's two-tailed test, we multiplied by 2. And as you can see, we have the answer here. P value is 0.549669363, and we write it with a few decimals. Clearly, it's larger than alpha of a 0.01. Therefore, the result is do not reject or fail to reject. 0, the claim is false. There is not sufficient evidence for the claim that there is a difference in the measurement of the muzzle velocity between device A and device B. You can also do confidence interval because alpha is 0.01 and this was a two-tailed test with a 99% confidence interval. Can be done by hand, d bar plus minus e, where e is t s over h squared omega. We plug in the values, we calculate e, d bar negative 1.3167 plus minus value will result in the value of mu calculated by hand, or you can put it into a TI calculator, resulting in the same value as you can see here by a TI calculator. It's contained in the interval. The decision is to not reject the null hypothesis.